Hello class, good morning. Class, today we are on assignment number 3 and with the help of this video lesson I will help you the ideas and concepts which will take you closer to the correct answer. So assignment number 3 for today's lesson and we are going to discuss diffusion. So let's see what's in it. We begin with the MCQ discussion and the first MCQ is which gas diffuses at the same rate as nitrogen gas? Now before getting to this activity, first you need to read the topic diffusion from the textbook. Diffusion is the mixing of particles due to random motion, and diffusion is always taking place when the gases are moving from a place of high concentration to a place of lower concentration, and the main factor on which this is spreading depends or based on is the molar mass, the relative molar mass. So if a gas is lighter, it will be mixed up faster, and if a gas is heavier, if its particles are heavier, then it will take longer time to mix together. And with this concept we solve number 1 MCQ, which gas diffuses at the same rate as nitrogen gas? So nitrogen gas has the molecular formula N2. It is a diatomic molecule. So one nitrogen atom weighs 14 grams. So two atoms must be weighing 28 grams or atomic mass unit. So you have to see the rate, the comparative rate with nitrogen is the comparison of any of the gas by means of its molar mass to nitrogen gas. So you calculate all the given options, molar mass, then compare it with nitrogen, you will get your answer. Next is which property of a gas affects the rate at which it spreads throughout the laboratory? Again, the concept is same. To solve number 3, let's see what's shown here. An attempt was made to compress a gas and a solid using the apparatus down. So these are the piston over cylinders on which gas is taken, and the piston can move up and down like this. When a piston comes down, the pressure is applied and the gas is insulated in this fixed volume. So we see which substance would be compressed and what is the reason. So there are 4 different options in which 2 kinds of substances are given. Suppose a gas is taken in the cylinder and a piston comes down. Then for option A, okay, this is not possible for solids because we know that after studying deeply the kinetic particle theory, we know that the solid particles are very tightly packed together and they have no spaces between them. So solids cannot be compressed, but this is possible for gas. So option C and D are omitted from my list. Now we have to think about A and B. Option A is telling us the gas particles are closer together. No. This is wrong concept, that the particles are very far from one another. They are having very least binding forces, intermolecular forces, and the particles move independent of one another. So again option A is omitted. We are left with only option B. Just confirm your answer. Number 4, oxides of nitrogen from car exhausts can spread through the atmosphere. So we see the exhaust gases are coming out of this pipe, of the silencer pipe. Okay, This occurs because gas molecules from a region of 1 concentration to a region of 2 concentration. Okay, in the beginning of this video, I explained the very important facts about diffusion. You have to apply this concept now. If a gas particles are spreading, they are diffusing. Okay, they are not evaporating. So option number C, B and option number D is omitted. We have to think of diffusion now, not the evaporation. So we know that when a gas diffuses, its particles move from high concentration to low concentration. So you have only option A and C in your list and you select the correct answer. Number 5. Heating a liquid causes it to become a vapor. Yes, we know that. What happens to the molecule of the liquid during this process? Okay, you have to see, do the molecules become bigger or the molecules move further apart? So this is the concept that there is no change on the shape and size of the particles of the molecules, only their intermolecular distance increases or decreases, and their kinetic energies and their relative binding forces strength when a substance changes its physical state. So you have to see in which category the correct answer is lying. To discuss the theory section, the first part is explain diffusion. Okay, you can do it. So next part is how diffusion supports the particulate nature of matter. On what factors the rate of the diffusion depends. Again, when you are going to explain diffusion, both of the sections will be answered. How does it support that the particulate nature of matter really exists? So you can support your answer by defining diffusion and by taking some of the portion from kinetic molecular theory, and you can also give some of the evidence of Brownian motion. Okay, the next part is bromine is a liquid with a low boiling point and a strong smell. A technician spilled some bromine in the corner of the room which is free of draughts. After 30 seconds, the bromine could be smelt on the floor on the other side of the room. Okay, the room is isolated. There is no opening and entering side of the room. And after some times, the scientist is smelling the bromine all over the room. How it happens? You have to explain it. That bromine particles are in liquid state, and after some times when it gets evaporated, the particles get spread in the room, and you have to explain this process of diffusion with the help of kinetic particle theory. Just try it, and you know this question is taken from the topical. You can go and study it in the topical worked out solution, and don't copy the answer from the solved paper. Just compose your answer yourself. I will highly appreciate it. Okay, class, try to solve this activity. You know that always I used to upload my videos on the channel, YouTube channel. So wherever you miss some lecture, you can go on that channel and you can find all the videos are lying there, and there are many more videos which will be very helpful in understanding chemistry and understanding the concepts with the help of examples. So just use that channel, because I have made this channel just for your benefit. Okay class, thank you. God bless you and take care.